I'm going to be talking about relations and functions. A relation is a set of ordered pairs which can be plotted on a graph, such as the set 1, 2, 2, 3, and 2, 5. If we draw some coordinate axes, the x-axis representing the first coordinate and the y-axis representing the second coordinate, we can plot these points. So the first one, 1, 2, would appear about here, if this is 2 on the y-axis and this is 1 on the x-axis. Then 2, 3 would be about here, and 2, 5 would be 2 points above it on the y-axis. When dealing with relations, two important notions to consider are the domain and range. The domain of a relation is simply the set of all first coordinates of all the points in the relation. Here we have the set with 1 and 2. Notice that 2 appears as the first coordinate of two different points in this relation, but that's okay. Next, the range is the set of all second coordinates of these points. So we have 2 from the first point, 3 from the second one, and 5 from the third point. So the range is 2, 3, and 5. Now let's look at a particularly important kind of relation called a function. A function is a relation that satisfies the following property. No point in the domain can correspond to more than one point in the range. For example, if we have 0, 1 and 0, 2, this is not a function. That's because 0, which is in the domain, corresponds to both 1 and 2, which are in the range. Let's look at something that is a function. Say the set containing 1, 1, 2, 4, and 4, 7. We've already seen one way that you can picture a function or any relation, which is by graphing the points on coordinate axes. But for a function, it's often useful to visualize it as a set of points in the domain, 1, 2, and 4, a set of points in the range, 1, 4, and 7, and then arrows pointing from the domain to the range, like this. Here we say that the function maps each point of the domain to a point in the range. So 1 is mapped to 1, 2 is mapped to 4, and 4 is mapped to 7. Up until now, we've been defining relations and functions using sets of ordered pairs. But most functions and relations that we'll be dealing with have infinitely many points in them, so you can't really define them like that. Usually we'll be dealing with relations and functions which are defined by equations. We think of each point in the function or relation as the ordered pair x, y, which satisfies some property. For example, y equals 3x plus 1, or x squared plus y squared is equal to 9. These are much more useful to look at with a graph. Let's plot both of these and study their properties. For x squared plus y squared equals 9, it'll actually end up being a circle, like this, and it'll have a radius of 3. And these are the x and y axes. For y equals 3x plus 1, we just get a line, which looks like this. So if we look at the graph for y equals 3x plus 1, it's pretty easy to see that given any x value, there is only one y value that matches it. So this equation, in fact, defines a function, not just a relation. For x squared plus y squared equals 9, we actually don't have a function, because at, say, x is equal to 0, y can take the value either 3 or minus 3. In fact, if you graph any relation, it's easy to tell whether it's a function by simply drawing a vertical line down through it at any point. If there is a vertical line that can be drawn which crosses the graph more than once, here and here, then it cannot be a function. This is called the vertical line test. If we try something similar with horizontal lines, then we can actually define a useful property of functions called one-to-one. If we draw a horizontal line and it intersects at only one point no matter where you draw the horizontal line, or at most one point, then the function is called one-to-one. Another way of saying this is that for any point in the range, there can be at most one point in the domain that corresponds to it. We can see here that y equals 3x plus 1 is a one-to-one function.